This is the, oh, what is it? Oh, okay, here we go. Writing and evaluating a function modeling continuous exponential growth or decay given to outputs. So we've got at the beginning of a study, a certain culture of bacteria has a population of 810. The population grows according to continuous exponential growth model. After 19 days, there are 972 bacteria. All right. A, let T be the time in days since the beginning of the study, and let Y be the number of bacteria at time T. Write a formula relating Y to T. Use exact expressions, that's going to be a pain, to fill in the missing parts of the formula. Do not use approximations. Okay, so we have the basic, really, formula here. We just have to remember which of these two boxes is which. So this box that's kind of out front, the coefficient, that's the initial amount. That's always the initial amount. And then this box next to the T, that's the rate of growth. And so that's what we're going to have to figure out. Okay, let me get something where I can write. Probably should have done that before I started the video. Here we go. Okay. So we've got beginning of the study, population of 810. Okay, so we can go ahead and actually just put that in right there. So then to get our rate, and this is also going to be a little ugly looking, but that's okay. We can type it in. So the rate is going to come from these two basically points on the equation or on the graph if we were to graph this thing. So we know that at time t equals 0, oops, it's 810 cells. And then at time 19 days, it's 972. So we filled in to this formula, the 810. We've put that in there. So now we're going to use this point to find the R. So kind of the general form, I just think of the continuous compound interest formula, A equals P e to the RT. But this is applicable to any situation where you have continuous exponential growth or decay. The P is your initial amount, R is the rate of growth or decay, and A is the final amount. Okay, so we now know that after T equals 19, our final amount is 972. So plugging that in, 972 is equal to, okay, P is 810, e to the, we don't know R, but we know that T would be 19 days. All right, so by the way, they're using Y here instead of an A, obviously. Okay, so now we need to solve for R. So first thing, just kind of with a exponential, no, I'm sorry, this is an exponential equation. Like with a linear equation, you sort of start further away from what you're solving for. So undoing, kind of working your way from the outside in. So the first thing we need to deal with is the 810. And so 972 divided by 810, I'm going to see if I can simplify that, but we don't actually want to write the decimal unless it's a terminating decimal. But if it goes on for a long time and we would want to say round, we actually don't want to round, right? Because it said do not use approximations. So let's just see what we've got here. Okay, it was 972 divided by 810. Oh, that's actually not bad. Okay, so let's do that, 1.2. So if it had come out to 1.289 blah, 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 going on forever, then we would want to see if we could maybe simplify a little bit. Like, it looks like both of these numbers could be divided by, say, 9, but we don't have to really worry about that. I think that Alex should be okay with us just using 1.2. We'll see when we get there. Maybe it would rather have a simplified fraction, but we'll see. So we now have that 1.2 is equal to e to the, let me write this as 19 times r. So now this is the kind of new part. We need to get the 19r out of the exponent, and the only way to do that is to take a log. Since it's base e that we're working with, let's do log base e, or the natural log, ln. So that's an L. So L of 1.2, ln of 1.2 equals natural log of e to the 19r. So you can skip writing this bit, because remember, the whole point of this is we're getting that 19r out of the exponent. Or you can think of, you're just rearranging this exponential equation to be a log equation, and so you end up with natural log of 1.2 is equal to 19r. Okay, so now we're almost there. We just have to divide both sides by 19. And so you could put natural log of 1.2 over 19 into your calculator to get an approximation. I don't think it's going to work out to anything terribly nice. So remember, Alex, though, doesn't want an approximation. They want a exact form. So natural log of 1.2 over 19, we're going to see if we can just actually type that in to the R box. So let's see. All right. So we've got these two things here. So let's do the fraction and then the natural log. So kind of give you a hint that you should be using natural log. So here's natural log of, oh, what am I doing? 1.2 and then 19. Okay, so now we're going to use this to solve B. So B says, how many bacteria are there 21 days after the beginning of the study? And so you may not need to write a whole lot down. Oh, sugar. Okay, but it's not a bad, oh, what did I just do? Oh, wow. Okay, it's not a bad idea, I'm sorry, oh, there we go. Go ahead and write it down, especially, if this was a test question, because it's super easy to put this stuff in your calculator incorrectly. So we are going to plug into this thing. So y equals 810 times e to this awful expression, I guess it's not that bad, times t is 21. So e to the natural log of 1.2 divided by 19 times 21. This is probably something you don't really care about, but by the way, there is a way to write this so it doesn't look quite so awful, although it's not what it looks like when you put it in your calculator. So since e to this whole bunch of stuff comes up pretty often in science and whatever applications, you might at some point in your life see something like this written as 810 and then exp parentheses. And then everything that's in the exponent. And it's just assumed that the base is e. So natural log of 1.2 over 19 times 21. And that might be written a little bit differently, but that way you're not trying to write it in teeny tiny exponent form. It makes things a little bit easier. Okay, anyway, sorry. So 810 and e to the, where is it? Natural log 1.2 divided by, oh, I don't want that, because notice that is, okay, undo. We don't want that divided by 19 inside the natural log, so I'm going to click, outside the natural log, but still in the exponent, and now do divided by 19. Okay, and then we want to do times 21, but not in this denominator. So again, I'm going to try and click right next to that and do times 21. You could also put the 21 times up there with the natural log, as long as it's not inside. Okay, so here we are. What does it say? Round to the nearest whole number. So 991. All right, moment of truth. Yay! Okay, so it was okay with us doing 1.2 instead of the simplified fraction, so that's good.